Hello, welcome back to Raw BM 101, an introduction to bioinstrumentation. In the last lecture, we talked about temperature measurement, as well as thermoresistors and thermocouples. In this lecture, we'll be discussing biochemical analysis, such as blood gas sensors and Clark electrodes. Blood gas sensors are used by physicians to measure the blood gas. You could administer mechanical ventilation or use it to administer pharmacological agents. They provide information about the respiratory and metabolic imbalances in the body and reflect the adequacy of blood oxygenation and CO2 elimination within the body. The machine works by using the non-invasive measurements of the diffusion of oxygen and carbon dioxide through the skin, as shown below. A Clark electrode consists of a silver anode and platinum cathode suspended within an electrolyte, as shown below. A current is generated as a result of the redox reactions within the electrolyte, and the current increases as the bias voltage increases. When the current plateaus, this correlates to the oxygen saturation within the body. A blood oximeter is used to measure the oxygen saturation within the body as well. 98% of oxygen is carried inside the body as oxyhemoglobin, and oxygen saturation is relative to the amount of HbO2 in the blood. As mentioned before, oxygen saturation can be measured with an oximeter, and the method is based on light absorption properties of blood. When blood is deoxygenated, it is blue, but when it is fully oxygenated, it is bright red. Therefore, by using different wavelengths, we can determine based off of the absorbance spectrum how much blood is fully oxygenated versus deoxygenated. As shown below, at 660 nanometers, the difference between the light absorption of oxygenated and deoxygenated blood is maximum, while at 105 nanometers, there is no difference between the light absorption at all. With these two values, we can then determine the difference between the two and calculate the blood oxygen saturation.